So I need to ask you what's inside that bag. Quantum computer. The smaller one. Guys, thank you very much for your participation. Great honor having you here. And my first question is to both of you. I remember our last one conversation yesterday. What is it? Sorry. Oh, okay, the prototype. Yep. I remember our yesterday conversation that only 10 people, scientists, work with you using your quantum computer. Poland loses quantum talents. Doesn't your off-the-shelf by outpace Professor Tomza's slow in-house vision? Yeah, that's right.
Hello. So, yes, in fact, this is the problem. We can build quantum computers, we can buy them, but the problem is to use them. I am the computer scientist, so I just found the people for computing, and the problem is that classical studies of computer science learn classical algorithms, classical, even sequential, not parallel algorithms. So the problem is the quantum gates and the idea of superposition and so on. It's completely different from the old school, real old school of this what we learn the students. So the problem is not for achieving the machinery, but for using it for real life. In fact, big companies as IBM or D-Wave show us the great vision that you use it for logistics and so on. And in fact, it can be used, but firstly, we have to just program it. And we have no programmers for quantum computing.
Is it useless for you?
No, I am maybe a different one because I can do it, but for make it more popular, we have to learn the students. So we have to start the studies of quantum computation, quantum computing, not even quantum technologies, but the higher level for use the technology and make the teams and make some people together to make the science for real life.
Michał?
Yes, so maybe first I start that we were presented as opponents, but I think it's not really the case because we really share probably the vision that we must support quantum technology, development of quantum technologies in Poland. So
that's not what I expected.
Yes, so the only question is how to do. And then I have quite strong opinion on this. And I think exactly what Professor presented already in the introduction, that for example, 5-qubit quantum processor may have very high didactic value, but it does not have any commercial value and almost no scientific value. And if we are aware of this, if we somehow can distinguish a bit what is really the scientific value, what is the commercial value, what are the practical values of quantum processes, I prefer to tell about quantum processors rather than quantum computers because they are not yet useful for commercial applications. So this is why I prefer to stick to quantum processors rather than quantum computers. But if we are aware what we use them for, what they can be applied to, and we somehow kind of try to control overhype, because this is also something that is maybe potentially dangerous when we see the press releases that we have powerful quantum computers provided already operational in Poland, and then we ask the question what they are useful for, and there is no commercial usefulness, and there is also no scientific. So I was rejecting scientific papers 5 years ago that were using the quantum devices that now we are buying. So this is the problem, that we are a bit buying the yesterday technologies instead of developing tomorrow technologies. And I think the only difference is that I think we should somehow decide, do we have enough money to somehow buy the devices instead of trying to maybe develop a bit like Bielik. I think Bielik is perfect example, right? So this is the question.
But this is non-commercial. But this is not commercial project.
But it has very high scientific and development technological value for Poland. It's not competitive with OpenAI at all, right? But we can also ask the question, do we want to pay lots of money to OpenAI for using their state-of-the-art even machines, or do we want to develop some local, still competitive? Because during the audience, I have the colleague working on Falcon in Abu Dhabi, so I just tried to compare, right? And somehow still our Bielik, although it's a bit smaller, it's competitive with the company that is supported by lots of Abu Dhabi money, right? So I think this is quite impressive, and I think we also should try to aim on the very similar approach for developing quantum processors, quantum computers, right? We should maybe try some particular architectures, particular application, particular technological questions that we could try to develop in Poland and contribute to the scientific market to be mentioned, because today during the first lecture, right, there was no Poland mentioned, right? On the map with the investment money, Poland was brown, right? So black. There was no money from Poland. There was no quantum computers mentioned in Poland. And I think even if you buy 100 of the yesterday quantum processors, we will still not be mentioned in the slides as during the first lecture, because only the developers of quantum processors were on this slide.
Okay, so where is your Polish quantum computer prototype to rival Wojciech vision? Or maybe this is just only idealism?
No, this is the problem. So this is the problem that we are not developing at all at the moment. We have some groups that dream about this, but this is also very expensive, and this is somehow the question. Can we, what should we do, right? Should we invest maybe this 10 million euro because 10 million euro is already enough money to really back up the very competitive research group developing some aspects, some elements of quantum computing, right? Instead of buying 20, for example, qubit quantum processors for not clear applications. So I really try to urge us to think, okay, what is the best investment? If we don't have unlimited money, is it better maybe to kind of design some path, design some target groups and try to attract some quantum developers and then develop quantum engineers. So I fully agree, we have to develop quantum coders, right? Because I think this is the Professor idea and Professor Elm, and I think it's very important as well. We need quantum coders, we need quantum programmers in the future, but I also think we really need quantum engineers that will be developing the devices, because otherwise it may be as with many other technologies that at some point US or Germany or other countries may decide, okay, their quantum processors are too important to share and will be cut off. And then what we can do, right? We will stay without this technology if we don't develop them inside in Poland.
Wojciech, do you agree?
Yes and no. Yes, that we need, of course, the programmers. However, you see what happened, and nowadays maybe we will create no programmers but prompt engineers, yeah, that to write, ChatGPT write me that and something. But of course we know that AI can create something which is combining what is it, yes? So if we have Shor algorithm and QAOAs, yeah, so and so, we can use it, but to invite a new one, AI is not good in creating new things. Yeah? It takes from the shelf, by the way. Yeah? But I don't agree that we can buy yesterday processors. Yeah? We bought in Wrocław 5 qubits machine from IQM, but in fact this is very good from the fidelity point of view. So in fact, it's what we have additional support that we can upgrade this machine, and in fact we have.
But yesterday you said that 5 qubits computer, even it's useless for quantum algorithm testing.
It depends, yeah, of course. If you can solve it for traveling salesman problem for 1,000 cities, it is impossible. You can solve it for 4 cities. What is it's called toy example? Yeah. So if we try to solve real life instances, this is useless. But if we take it for scaling just for write small algorithm and say, if we have greater machine, we can use it, the same code, so it works, yes? We're just waiting for increasing the machinery. It seems that it's happened, yeah? So nowadays we have 5 qubits for about €1 million. So this is plus minus 10 times less than we have to pay for creating this technology. So we start from the helicopter in the Himalaya, yes, and we start to the K2 or something, just for upper level and say, let's keep how does it create. We just try to learn, program it.
How many qubits do you need to make it useful?
1,000. And in fact, 10,000 is to crack the RSA algorithm for 2,000 bits.
What's the cost of such computer?
It starts nowadays in Chicago. There is a company which takes as I remember, 10,000 or $100,000 million for creating 1 million machine, and it's happened now. It is engineer problem. In fact, this is not scientific way. It's just a number of wires we have to put together, make this huge refrigerator, of course, in fact. And it is possible nowadays. Of course, we have the problem with noise and so on and so on. Google creates the quantum noise reduction algorithms and so on. So in fact, we have some scientific machinery. The problem is to make the real working one.
Michael, you would like to say something?
Yeah, no, so I think that somehow it's also very important that, like, okay, we will be still always behind the state of the art when we buy from the shelf, right? So because we'll never get the current state of the art machines. We may not even know what they are working on in their headquarters, right? And in the end, in the long term, if we properly play it, it may be that developing it may be cheaper, especially if really we start thinking about buying 1,000 qubits machines at some point. There will be really going into hundreds of millions, million euro at some point. So it will be too expensive for us. So I think that we really need this parallel. And I think I can also give an example. So my former master student, he is now PhD student at Harvard, and he develops quantum computers that are based on neutral atoms, neutral cold atoms in the Era Computing company, right? And this is really that there is, in one building, there is laboratories. There are laboratories where graduate students and postdocs work on developing some technologies. And then there is next building when there is startup with hundreds of $million funding that try to develop 1,000 qubit processors, right? And I think this is the way. Without this, we will really be kind of just the receivers of some technology, but we will never be in the race. We will never win the race, right? There is no way to win the F1. I like to compare this to F1 races, right? You cannot win the F1 competition when you buy the car from the last year competition. You really have to develop something that is state of the art, and this is my perspective. That is very important to have the ecosystem, to have the engineers.
This is very good comparison. I also like this automotive comparison because if you would like to win the F1, you should buy the engine, probably from Honda or from Mercedes. But if you try to build engineer by yourself, this is 50 years for working. Yeah.
On the audience, we have representatives from some environment sectors, from lawyers, physicists, mathematicians. So what's the biggest limitation for quantum computing development still? Professor Marek Żukowski think that is the blind way of development. What's that missing link? What's missing in the quantum computing development? Michał, Wojciech.
I think still, so first of all, I really like to think about developing quantum processor, quantum computer as still very beautiful physical challenge.
Vision.
No, not vision. No. There is, I think that, of course, on one hand side, there are clear paths where the developments go, but I think we are not 100% sure if we increase the size from this 100 qubits or 200 qubits to 10,000 qubits, if everything will be as we expect. So this is not yet proven, not guaranteed, right? So this is one of the challenges. We may at some point reach some plateau, and then there will be conceptual challenge to overcome. But this we don't know, right? So I think that we are a bit unsure in this. And of course, it's always that, like with many other technologies, right, with LLMs, right? So it may be that some very clever idea may overcome some processes. And this is why still in quantum computing, right, there are many different technologies developed. And the idea, and this is why, this is really somehow even Microsoft with somehow his very long vision of their topological qubits, right? So it was clear for many years that they were much behind the other technologies, but still, because it's not sure which technology can really scale to thousands or hundreds of thousands of qubits, this is so important to develop different of them and kind of really bringing the best minds to maybe get some really out-of-the-box idea for some completely different ideas. So I think that we hope that the current scaling, current developments will continue. It's not guaranteed. So this is why it's so important to still think about, let's say, discovering new type of engine really, right? Or because it's not guaranteed that it will work for sure when we just take better quality, better control, better, larger numbers of qubits.
Yeah, I agree. And from my point of view, so from the point of view of programmer or computer scientist, the problem is the short, long life of the qubit. It lives for 40 microseconds, yes? And the number of gates, quantum gates we can done through this time is about up to 2,000. It is the most. It is a very, very short program. If we think about classical program in assembler of machine code for the classical CPU, this is almost nothing. You can write hello, maybe not word, but it is too long. Yeah. So this is too short. So of course, if we have cold ions, the time of solving is about 1 minute. But the making quantum gates is much longer in this technology. The technology which uses IBM or IQM or Google or Microsoft, we use these transmon qubits, and they are quite fast in making quantum gates. For other technology, which make the time of usage of qubits longer, also the time of making this on these ions is longer. So for us as programmers, this is still the technology which make possible too short programs. And after this time, the qubit collapses and we have to start again. So still technology is too weak.
I think that exactly this statement, the technology is at two initial stages, is the argument to develop still in-house.
Okay, if it's 2 weeks, so what's your vision for your laboratory development?
No, other matter is just creating the algorithm. As I said on the beginning, we have about maybe 10 good quantum algorithms, and the book of Introduction to Quantum Algorithms is still not very big, because the number of real new algorithms is not very big, just from the point of computer science. Yes, so we have to create new algorithms for new problems, and not just combine the previous one and not using the classical and combine it with making this a kind of hybrid. So we have to think about a new way to solve old problems. And it is like this studying. Yeah? We learn people, old technology. Even not parallel computing, this is sequential algorithm, and we learn Dijkstra algorithm and so on for making a shortest path in the graph. But if we think about shortest path in the graph from the quantum point of view, we can say maybe Grover, something. Yeah? So there are no new algorithms for this new technology.
Mm-hmm. Michał, you said that we should be focused on creating new kind of engineering. Is somewhere any place in Poland where such experiments are conducted?
Yes, of course, we have few experiments. So on one hand side, the quantum theory in Poland was always strong. Like the Gdańsk is the kind of origin of Polish quantum information theory. But of course, we have few experiments. I mean, in Warsaw, we have few groups that try to develop some aspects. There are in Toruń, some Kraków, in other places
Michał
as well.
Parniak?
Yeah, Michał Parniak is, I think, one of the examples. We have Barbara Piętka, who is more from the solid-state physics, also using the devices for quantum applications. And I think that the point is that this is exactly the question. If we can spend this tens of millions of euros instead of buying some devices to put this money for the most talented people like them, because I'm doing theory, so I'm rather helping my experimental colleagues, but I'm not doing any real device with my hands, I'm sorry. But if we can give this kind of money for these talented people, if we can attract some talents globally, because there are many talented Polish physicists, quantum engineers around the world that may be happy to come to Poland and develop their labs, contributing to this cutting-edge quantum technology, quantum computing technologies, if we can attract them. And we already with the, tens of millions of euros enough to really start, not maybe the competitive startup that can be the leading startup providing quantum processors, but for sure establishing the very competitive fundamental quantum research for quantum technology lab in Poland. So, and this is something that we should really kind of think how to do, because like the funding now we have is probably too small, right? With the National Science Center money, it's very hard to establish competitive lab developing quantum technology, but just giving 5 times more, like instead of 2 million zlotys, giving 2 million euro for starting the quantum lab, it's already something that may be good initial. So of course, it's a bit more than this kind of, yes, the kind of 1 million euro for 5 quantum qubit devices, not maybe a
when
big
we
problem.
are talking about Michał Parniak, mention Michał Parniak, so because he's working under quantum processing, this is quantum processor, right?
Yeah, this is for 4 qubits quantum processor, of course, in the plastic.
Yeah.
But this is the previous version of the processor we have.
From
in Warsaw.
IQM, from Finland,
yeah,
right?
yeah. This is transmont qubits. Okay, of course, this it must work in the 10 millikelvins temperature. So the problem is this refrigerator. But the technology is ready. However, we know, as you say, that we can create such a technology. The matter is just put the money for the group of people which makes nanostructure like this.
Money plus talent and experience.
Yeah,
this is something that unfortunately the know-how that is now behind these devices is really, really advanced, and we really need people who somehow transfer this knowledge from top places in the world. So this is something also very important, that we are not drained from talents, but we attract talents. Even like just Polish citizens working abroad for a long time, if we can attract them to kind of develop this technology. This is something I think very important that we remember. If we want to be in the ecosystem, if we want to be on the maps presented in the first lecture today, we have to attract back these people and help develop local engineers, local scientists, local physicists, local quantum computer scientists that can contribute to this.
Before I will give the opportunity to ask some question from audience, what's wrong with us? Why we have no Nobel Prize? Why we have no Dirac Medal Award, Turing Award, Fields Medal Award, Newton Award? What's wrong with Polish science? I think Polish physicists.
No. I would say part of the problem is, for example, yesterday we could see the project of the budget for Poland, and we still stay at 1.1% of GDP for research, right? And Israel or Korea or Finland are spending 4%.
But Romania have Nobel Prizes, having less budget for science than Poland.
But still, there is no, I think without long-term vision, long-term investment, we don't have really good plan as a country how we would like to be in 10 years. How do we want to keep our very successful economical developments from the last 30 years for the next decade? And I think without research, without this kind of deep tech development that must be really rooted in the local research, we will not continue this. And I think this is really like many years of not putting enough effort into developing our local research from fundamental, because this has to be ecosystem. We need to have very strong, this is what we can see here in Gdańsk, right? We have very strong quantum theorists, right? And these quantum theorists can really attract top talents from the world, right? So I think that here in this institute there are postdocs, there are graduate students coming from Germany, US, probably UK, and not only the poorer countries, but also the top countries, right? And this was possible, right? So I think if we can repeat this kind of stories, but in the other topics, then we will have the critical mass of intellectual capacity that can really support more applied research, and then of course all the startup and all the economical, hopefully, developments.
Wojciech?
Yeah, I agree. The problem is money. Yeah. For instance, the computer we have bought in Wrocław, this is just the money of university. This is not government money. So this is $1 million. This is for the university. This is maybe not nothing, but not very big enough. Of course, a big computer costs $100 million, and we need something from the government to make this. Poznań was able to make such a deal. Yes, they has 20 ion traps qubits, also for government. But this is as a
Don't you think
F1.
that it's something more?
No.
You know, it's very easy to say that's not about me. That's only about money.
No. This comparison to F1 is very good because we have Kubica, yes, but we don't have F1
Environment
team.
round.
Yeah. We need money to make this whole environment.
But I think this is money spent over time. So these examples, like we bought for Poznań, they bought the device from Innsbruck, right? And the startup that was created maybe 5 or 10 years ago was based on more than 20 years of development of really top minds doing just fundamental physics, right? The Blood, Zeilinger in now Vienna earlier. There are few other names that are the biggest name in the world in quantum physics. And initially they didn't really think at all about whatever commercialization. This was really fundamental. And this 20 years of very good vision, lots of investment in this part of physics resulted in this startup. And the same is in Boston, right? In Boston, the other quantum computing devices, right? There are 3 top professors from Harvard, MIT, that 5 years ago started the company. They collected more than 200 million, maybe now more dollars for starting this company. And now they are in the race. So this we should be aware that we need this backup from deep research developed over decades to be competitive. And while we are spending next and next years not changing our approach toward research, and we are then surprised that we cannot start the startups based on the deep tech. So I think this is something good, and we should be aware that, of course, then the money is needed, right? So as I mentioned, the startups now to start competitive developments in quantum processors, right? This is hundreds of millions needed to start, right? My collaborator from Weizmann Institute, now he's developing the new type of quantum processor, the most powerful Israeli quantum processors. And just in the first year, when they started, at the beginning, they started from $30 million as a seed money for their startup. Now they go over 100 million. And this is kind of the money that there is no in Poland, or somehow there is no clear vision path how to get them if some of the top researchers would like to really start be competitive.
Don't you think that the era when we need to work 10 years, 20 years for a Nobel Prize, it's over? Look at Demis Hassabis. He's Nobel Prize winner and he started his work 10 years ago.
Yes, but still his achievements, they were really based on the decades of development, right? So, and we can also look on the OpenAI, right? So before they went public, right, there were 5-7 years of very hard, deep research. So I don't think that this is really, I never believed, and I don't think that there are like this, spontaneous geniuses that are coming out of nowhere. No, all these kind of great minds, they are coming from the years of their hard work, or great teachers, or mentors, or collaborators. And somehow, of course, you need to have this kind of smartness to connect the dots. But you will not do it in basement, you will not do it in the desert, right? You need the very supportive, very competitive, very kind of advanced environment to kind of create this kind of minds to support them for this.
Wojciech?
Yeah, I agree. This comparison to the AI is very good. My colleagues from my university learn works on large, or in fact, natural language processing for 30 years. And for 20 years, nothing happens almost. And nowadays, if we have NVIDIA machines and 1 megawatt supercomputers, and we put these millions of inputs, it works. So nothing changes except money for this huge machine. It takes 10 kilowatts. AI takes in Wrocław 1 megawatt, just for learning the model. So this is the kind of machinery and the money for for this.
Okay, you just said that we have no strategy. Who should create such strategy? Strategy.
Yeah, so I think that scientists, quantum physicists try to talk with politicians and other people who can help and decide. And I think there are some problems. There is lack of vision. I don't know what is the problem really, but I think this should be kind of collaborative efforts of the scientists, of the people from the startups.
Maybe
of the
people
government.
like you.
I mean, we try to
You
do it, right?
are well-recognized young generation physicist. Maybe this is your responsibility for that.
And we try to talk with politicians, we try to talk with other stakeholders, but this is the problem. Like, as I mentioned, because all the investments, all the plans, all the strategy has the time scale of decades, so maybe 5-10 years, and this is far beyond the scope of politicians, right? This is the big problem, right? So they are not really kind of open for establishing some programs, some strategies that will support, that will give results in 5 or 10 years, because this will be far, far beyond the next election and election behind the next election, right? And this is, I think, one of the problems that somehow this is missing, right? I don't know how to overcome this. I think there should be I think this is important that we build, let's say, the social support for this, right? We have to make society aware how important developing the deep techs, how important is the developing the research behind the deep tech, that they kind of put pressure. And then when they vote, they will look at what is the approach of politicians to these issues. And this is probably the only, so we all should probably somehow be these educators for the society, convincing society that this kind of long-term investments into research, into the deep tech are essential.
And now I think there's a time for question from audience, and I see the first 1, 2, 3, so.
Good morning, everyone. My name is Wojciech. I represent local VC fund called Balnord. We are investing in frontier technologies, also in deep tech. And I can confirm that there is not enough capital to finance. So, gentlemen, I got a question to you. Maybe we can build value on a little bit different approach on top of the quantum computing race. Maybe we can use what is specific and we are really good at Poland, so building software on top of the quantum solutions, but not on the traditional ways, but the ways dedicated to this specific of quantum computing and using scientific methods. What do you think? Is it the chance for us as a nation or not?
No, for sure. I mean, the theory of quantum information, this is something, and Gdańsk is the global leader in this, right? And there are other places in Poland with strong contributions. So I think absolutely this is something that we should try, because somehow historically and for other reasons like theoretical physics, computer science in Poland was stronger than experimental research. And I mean, this is for sure the good starting points. I'm not sure why we are not yet so competitive in this part. We will see after the break some startups developing the quantum algorithms. So this probably will be a good question to them and their colleagues.
Yeah, I agree. And for sure, we have to make, we have very clever students, very clever programmers who are well known all over the world. However, to make the business from the quantum software is hard. Somehow, the only company I think in this moment is D-Wave from Canada, which makes a real business on D-Wave, on the quantum computing. However, they simulate quantum annealers, not general purpose quantum computers. However, in this year, they have about $30 million of income. So this is the place in which they sell something to Volkswagen, to Los Alamos, and so on. And so the computation they can make maybe even smaller than we can make on classical computers. But the marketing on PR slogan made by quantum start to work. Yes, so it is possible to make money on quantum computation, even if they just start. But we know that probably it will be exponential. So
Even in Los Alamos, we have great Polish physicist Wojciech Żurek. Now the question from Mr. Professor from Royal Swedish Academy. So guys, it's an important question.
I just want to say some comment. I think first is what it could be done is make a national quantum strategy document. We are not asking for money. You just make a map of how Poland is doing in quantum technologies, some history, and the main players, and academia, and industry, and so on. That's, I think, is a document could be done by you guys, you see. And there are many available documents of other countries available if you want to see how it's done, right? There are no money there. Then that document will be delivered to the state and saying, look, this is what we are thinking. And only then the state will make the initiative when this come money. But there are no commitment of the state when you're preparing this document. Just to tell them, okay, this is the strategy, this is what we think. And then they will, the state, decide to make an initiative or not. That's how in this order, right? Now, on the second, my comment, if you allowed me, this is about computer, right? To buy, not to buy, and you know. And I think many countries think that to want to build their quantum computer, and they fail in some sense because they not compete with large corporate and so on and so on. And then they have a choice what to do. Then they say, okay, what we do after spending a lot of money, by the way. And they say, okay, we use on cloud. You can rent, you know, the 125 qubits for free. But if you want a good one, like around 100 or so qubit or more, you have access to that computer. And that people from computer science, programmer, architecture, the people they will use this computer on cloud. Then you can also buy, as you have done more or less on this from IQM. To buy a computer, not to use it, but for people developing hardware, to test their own hardware. If you want to test, if you have developed some amplifier or filter or so on, you put it in that machine and test it and develop. Maybe you will be making this small chip that any quantum computer, I'm talking about superconductor based, will use this chip, and that you have win. That I think what one thing is like, but to buy a computer, spending a lot of money, and then after 6 months you will find that this computer, they are for free, like what happened, say in Sweden, they want to develop quantum computer for 25 qubit, and now people can access to that one for free from IBM. Then I think buying, I think is not the right approach. I think renting a time for good ones, and then it helps the programmer to test, or users, you know. Now in Sweden, we rent that computer on cloud, and then open for any researcher or developer that could access to that computer. And that's what I think. Thank you.
So if I can agree, I fully agree, and I think I can mention even some exactly. So I fully agree. We should use cloud for teaching our quantum coders, and we should look for some niches when we can contribute parts of the technology. And we have examples. For example, Cryotech in Warsaw, the company that provides the control systems for the top ion-based quantum computers, right? So both Oxford Ionics, both IonQ, they are using the electronics developed in Warsaw for controlling systems. I think this is a beautiful example. We will not develop this machine for $500 million because this would be needed to develop full quantum device, but we can find exactly the parts of this technology that we can contribute meaningfully, and then we can, in fact, maybe even make the top companies dependent on us, right? So this quantum, this control systems from Warsaw, I mean, the $8 billion evaluated IonQ company in US is fully based on using electronics from Warsaw, right? And I think this is exactly what we need. Other examples like this.
And last one question from you.
Okay. All right. Paweł Gora, Fundacja Quantum AI. So I would like to share a few comments and then ask one question to our panelists. So regarding the comments, first about the quantum strategy or quantum politics. So here in Poland, it's currently in the process of development. So a few months ago, I was also invited to work on this. So this is a good news that hopefully we'll soon have the Polish quantum politics, because this will be the formal name. So if anyone would like to talk to me what should be included in the strategy, feel free to do it during this conference, of course. And I fully agree with our panelists that having the strategy and having more financial support for science is crucial. But I also would like to share one interesting thought regarding Maciej's question that perhaps there's also something else. Because recently I had some interesting conversations with several people on this, why we are so good in some programming competitions. Many Polish people work for OpenAI and many great companies, but we do not have Nobel Prize winners, for example. And one of my colleagues who spent about 5 years in Switzerland and more than 10 years in the Silicon Valley, and then came back to Poland, told me that, in his opinion, money is not the only difference. There are also cultural differences, and their mindset is also very important. He later prepared a blog in which he wrote a very interesting and quite unique thought that we are culturally trained here in Poland to be world-class problem solvers, but not world-class problem pickers. So in our schools, we are trained to solve problems that are given to us by someone else. That's why we are able to win in Olympiads, mathematical competitions, because these competitions are about solving problems that someone else gave us, and all these problems are already solved by someone else, but we are not that good in picking the good problems. And when I look at the researchers, scientists in Poland, I also see that at least some of them probably do not pick or do not work on the open scientific problems that are meaningful enough to win the Nobel Prize at some point. And this is a question I wanted to ask, whether you think that this could be true, in your opinion as well, that there could be also some cultural reasons which may also, and at the end, the main reason could be historical reasons, of course, right? So I hope that it will change in the future. But when I also recently talked to people from the British Embassy, for example, about the British quantum strategy, how this quantum strategy was developed, I see that indeed there are some significant cultural differences as well. Thank you.
Guys?
Yes, I fully agree. So somehow I may even tell that a bit my own experience is similar. So I'm not very much talented, right? I don't have much mathematical skills, but I'm still doing quite well as a physicist, and I think this is exactly my strategy, right? So I don't try to solve the hardest problem mathematically that are meaningless. Really, I want to find some simple problems that can really impact lots of research, right? I can inspire experimental groups around the world, and this is my biggest achievement, right? That there are like probably almost 10 research groups around the world that I realizing my research ideas, right? Although I didn't solve any hard problem, I had just good ideas, and I think this is a bit missing. So this was also my experience as a PhD student, right? That in some parts of the research, right, the idea was first let's solve very hard mathematical problem, and then we will see if it's useful for something, right? And this is maybe not the best idea, because you can use lots of resources for this, but if it's not impactful, if it's not useful for something, it may be. But of course, there are also this kind of approaches needed, because you not always can predict what will be useful, right? So I think you have to be balanced, but I think this is something that this kind of soft skills, knowing how to go the right path, how to collaborate internationally, how really, because you need collaboration, right? You cannot do this, any scientific discovery in basement.
Wojciech, and one final comments from you,
Yeah,
because
so
we are over time.
So I don't agree. You know, Los Alamos and in general America is not a good example, because the greatest scientists, Einstein, Nikola Tesla.
Los Alamos, Oppenheimer.
Yeah. So, in fact, American people which born in America, this is not the most of them. Yeah, in most universities, the most of PhD clever students goes from Europe or India and so on. So the money rule the most, I think, because I think our students are enough clever to just create the problems, to solve them. Yes, and we have very, very good young people, but the matter is how to keep them here in this country and how to create them environment for making these big things.
Thank you very much for your time, and good news, now is a break time. Thank you very much for your attention.
Niestety, że tutaj chciałeś, żebyśmy jednak cię...